Hi friends, this is Krish here, and we are today live on various social media platforms like LinkedIn, Facebook, Twitter, Instagram, Trolls, Twitch, many platforms we are live today. And the purpose of today's live is to work on a production planning optimization case study. We'll be doing this case study in two different parts. One is today we will discuss the entire input and output parameters, the model parameters, and in the next session, maybe in a couple of days, we'll be doing the modeling using solver. So I hope I'm audible to you, all of you. So just I want to check the voice settings. So I hope yeah, I think the voice settings are working well. So let me introduce myself. I am Krish Naidu. I am a founder of a supply chain analytics consulting and training firm. Mathnal and our website you can see on the screen, which is www.mathnal.tech. So we'll be doing first we'll discuss the input and output parameters of the model, like its production planning. So I hope you are all working in a manufacturing environment. So manufacturing environment, there are some things which we need to which we need to think about before we build a model. So we are in real time scenarios, we are not allowed to work on free models, right? We are working under certain kind of constraints. Uh, so to derive the optimization. So first, let me discuss about the today's case. So today's case is right production planning optimization. So the reason why we need to optimize supply chain, why we need to optimize supply chain. Suppose if you have a supply chain, so your supply chain starts with supplier, right? And then the supplier which we have, he might be having n number of suppliers. So these suppliers will ship the product using a transport medium to the, you know, maybe a distributor or maybe your warehouse, right? And your factory will receive the good from the warehouse or maybe from the distributor, right? So now your factory has to produce the goods and ship the goods to the, you know, the distributors and the downstream, right? The distributors on the downstreams or maybe the retailers, right? And these guys might ship to the retailers, and retailers will finally give it to the end consumers. So this is simple supply chain is there. So we're not building the total complex supply chain. We're building a very simple supply chain. So factory, at the factory, what happens? The forecasting happens. Okay, and this forecasting happening for what? For volume, for value, right? And this volume and value forecasting is happening for various kind of categories, like product categories, right? Region categories, customer region categories, warehouse categories, right? Variety categories. So various kind of categories are being forecasted for. Now, what happens once you forecast for various categories? This product are actually has to be shipped on certain kind of time horizon. Right? So we need to ship the products. We need to ship the products to the region or to the warehouse, right? For of different varieties in a particular time horizon. So the time horizon is a very, very important part. So suppose you're shipping the volume per month or volume per week or volume per day, right? Or volume per 2 weeks. Okay. So you need to because if you are doing a production, but the production is not measured in terms of the time. right? Then you might not be able to, satisfy the customers. It's not customer. It's not. We have to make it customer centric. If you want to make it customer centric, you need to define your volume by time horizon, right? You need to make it revenue centric. You need to make it profit margin centric, right? So if you want to make it customer centric, revenue centric, or profit margin centric, we need to define our forecast by time. So say so this forecast is happening by time. So if I can if I have to distribute it further, it is volume per time per upstream partner, sorry, downstream partner, right? Or the value per unit time horizon by downstream partner, right? By product. So we are trying to bring the volume perspective, value perspective. We're trying to bring the time perspective. We are trying to bring the upstream partner perspective, and we're trying to bring the product perspective, right? So these all perspectives are coming. So moment we bring the time perspective, volume per time perspective, right? So our production has to meet those targets. So once we have a forecast that is volume per time per customer, right? So our production has to meet those targets so that we match demand and supply, so that we map demand and supply. So our production capacity must know the forecast so that we can tackle any bottlenecks which will come around. Right? So the most important thing is we need to define our forecast. We need to define the forecast volume per, or if your time horizon is month or week or day or fortnights. So you have to know what is the time horizon. The time horizon is a very, very important part, right? Forecast, more than forecast. The forecast cannot be forecast if you're not defining the time horizon. It's very difficult to work on the targets because business is all about time specific. So we have to know our time. What is our time for a production volume or for a forecast volume? So if I know this target very well, my demand, now I can actually work on my supply, the demand. And supply is coming from where? Supply is coming from the factory to the customers. Customers can be distributor, retailer, or end consumer, whoever it is, right? So if I know my forecast, which is per unit volume, which is volume per time, and we need to clearly define what is the time. So are you defining volume by 2 weeks or 1 week or 1 month or per day? What is your forecast? What is the time horizon? It's a very, very important part. If you're not defining the time horizon very clearly, then your calculations, the planning calculations or optimization calculations may may go wrong, and the impact of this can be seen on cost of goods sold. Second, on time delivery in full. on-time delivery in full, your days of supply, right? Stock out, overstock. So it is going to impact a lot of KPIs, and all of them are revenue specific and profit specific. So the objective optimization cannot be realized if you have the wrong time parameters. Okay, the objective of optimization is what? The objective of optimization is to derive or achieve the metrics as per the benchmarks. So moment you define a wrong time, you change even though your metric is defined for a different kind of time period or time horizon, but you have optimized for a different kind of time horizon. So that is going to impact, and so that particular disparity, the disparity in the assessment in the beginning can actually create a lot of problem. So it's very important that we define our time horizon in a proper way so that we don't have any issues later on. If you have any questions, please feel to ping me on my social media pages, right? So I will be able to reply immediately on the solutions. So here, so we are trying to understand our factory forecast capacity. Let me write a different diagram now. So this is my factory. So I am getting what forecast as a input, right? And what I'm going to deliver, I'm going to deliver the production as goods as output, right? So my forecast and my production, they have to be mapped. My production and the forecast, right? They both have to be mapped. So we are mapping in terms of two aspects. One is our volume, and other is our time. So we are going to produce volume. So water volume in a certain specific time, based upon the forecast, which is also volume at certain specific of time. So that's we are going to match. Now let's look at this one thing. So here, so what we need to see is that so the suppliers are shipping the goods, right, as raw materials, which are going to be used for production in the factory, right? So we also need to see that the raw materials which are coming into the factory, right, as an input to the production, they also should be they should have some kind of safety factor. For example, let's take a case here. Suppose this is my factory. So this is an input. Okay, there is an output, right? There's very kind of inputs, right? So now the forecast, let's say the forecast is 20 units per day, right? Like my production is, let's say it may be 20 or maybe more than 20 per day, right? But it's not less than 20. Now the raw material which is coming here inside the factory, right, for production. Okay. So do we need a raw material 20 units per day? Let's say the factor of conversion of raw materials to product is let's say 1.5, which means to produce 1 unit of product we need, right, 1.5 unit of raw material. For example, this is a scenario I'm taking here. So if I need to produce 20 units, if my forecast is 20 units, my production is 20 units, So my raw material is how much? Let's 20 into 1.5. It would be around 30 units per day. So 30 units per day is something what we need to do, or we need to go at least. Let's take a safety factor. Let's suppose if my forecast increases, or maybe if the next demand, if the next for the next demand, the supplier is taking some more time, is not able to ship and on time, right? In that case, I should not be out of stock with raw materials to manufacture the products. So I'm going to take certain kind of safety stock here. 30 units per day is the mapping. Plus, I'll take some, let's say, certain kind of safety stock. Safety stock is equal to, there is a different kind of measurement techniques out there for safety stock. So I'm not going to use the techniques over here. There's a different session. We'll go here. So let's say I'm going to take 2 days safety, 2 day, or let's 3 days safety stock. Okay, so 30 units per day is my per demand, plus 30 into 3 as my safety stock. The total raw material stock I should have is 90 plus 30 plus 90 is equal to 120 units, right? So I'm trying to keep certain safety stock for the raw materials, and that I'm trying to keep at least 3 days safety stock I'm trying to keep in the warehouse. All right. So what is the mapping technique we are seeing here now? The mapping technique is that the raw material we are keeping a stock for how many days? 4 days, right? 3 days safety stock. So 4 days of stock. So I'm saying that this is 120 units. Okay. Of course, consumption will be 30 units per day. That is not changing, but we're keeping additional 3 days stock for raw material. Now it is going to production. Okay. In the production, the forecast is the 20 units per day. Okay. So what I'm doing is I'm creating, 1 unit, 1 day extra stock. So 20 units per day plus, let's say 20 units per day, right? So additionally, I can create either, 0.5 day stock additional or 1 day stock additional, right? So let's say I choose zero point 0.5 days additional. So 20 plus 10 equal to 30 units. I'm doing this 30 units because I may have certain extra requirement from the customer, or I might have some kind of idle time because of the breakdown of the machine. So I'm doing this zero point 0.5 day extra production for two reasons, right? Because of likelihood of breakdown of machines, or we can have some certain extra demand from the new customer, or the old customers. Okay. So now what we have the ratio, what we look at here, the raw material ratio is that we are trying to go with some kind of safety stock, right? We are going for 3 days safety stock. And in the case of production, we are going with some zero point 0.5 day additional stock. The forecast is 20 units per day, but we are not going to produce 20 units per day. We're going to produce more than 20 units per day, but not less than 20 units. We're not going for less than 20 units. That is one of the constraints we're going to give. For 20 units per day plus zero point 0.5 day extra stock means if 20 units per day is a 1 day stock, for the 50% of the stock will be produced in 50% of the available production time. That is 20 by 2. So 20 by 2 is 10. So 20 plus 20 by 2. So this is equal to 20 plus 10 is equal to 30. So this is how I'm trying to manage my volume per unit time. So raw material, I'm going for 120 units. And the reason why I'm going 120 is 20 units in, because if to convert one unit of raw material into product, I need 1.5 units of raw material. So to get to this to derive 1 unit of product, we need 1.5 units of raw material. So if I have to produce 20 units of raw material, I need 20 into 1.5 times. So if 1 unit of product requires 1.5 units of raw material. Certain amount of raw material will go into wastage. So 20 units of products will require 20 into 1.5 units of raw materials. So which is equal to 30 units of raw material, right? So this is the ratio, and I'm trying to keep 3 days safety stock. This is 1 day requirement. I'm trying to keep another 2 days. So I'm trying to get 2 days of additional stock, or maybe let's say 3 days of additional stock. 30 into 3 is equal to 90. So 3 days of additional stock as a safety stock, that is equal to 90. And 1 day, which is 1 day production, which I'm going to use, that is 30 units, total 30 plus 90 is equal to 120 units. So if this is what we are trying to create, so 120 units of raw material, and the forecast is how much? 20 units per day, and the production is how much? 20 for the production, and we're trying to create 10 units extra, right? Because we want to have zero point 0.5 days of additional stock, because we are taking two scenarios into consideration. One is that the likelihood of breakdown of machine is very high. So that's why we want to take it into the trading call. Or if you get a demand from the customer, which a new customers may be asking for a new product, for a demand for a product, or maybe the current customer is asking for additional requirement. So in that case also, we are taking the consideration, and we are going to have 10 days of additional stock. So 20 plus 10 is equal to 30, right? So this is water production. So 30 units of production, 20 units of forecast, and 120 units of raw material. So here we are actually having, if these units, 10 units are not being consumed because of this break, if there is no breakdown and no, if there is no breakdown and no extra demand from the customer, so these 10 units will go into the inventory, right? So this is a scenario which we are taking into account. So I hope the volume per unit. So here the volume is per day, right? So we are going for per day. Forecast is per day. In production is per day. Okay, and the raw material consumption is also per day. So this is what the cycle. This is a cycle we are taking. Okay. So if you have any questions, you're free to ask on my page or any social media channel if you're watching them. So I'm just looking for some questions from the people if they have any. I'm just checking my social media page. So please give me a time. So just I'm just checking my social media page if they have any questions. So okay. So now let's move to the next case. So we have understood our raw material consumption per day, forecast per day, and we also understood our production per day. Okay. So now let's go and look at the new case. So now let's move into the input and output, other inputs and other outputs. For example, your forecast is 2000 units, which we had in a shift. Suppose we have a shift of 8 hours, right? So 8 hours is equal to 8 into 60, 480 minutes. So in 480 minutes, you need to produce 2000 units. That's a forecast. In 1 minute, how much you have to produce? 2000 by 480. So if I do the calculation of this particular thing, so this is equal to 2000 divided by 480, which comes around 4.16. So you know, 1 minute in 1 minute we need to produce 4.161 4.16 units. So which is, let's say, 4 units in 1 minute. So this particular concept is called takt time. So this is called takt time. So in 1 unit, in 1 minute, you need to produce 4 units. So if you produce in 4 units in 1 minute, right? So we are going to be able to meet our we're going to be able to meet our customer centric objectives. What are the customer centric objectives? We have already discussed that, like on time delivery in full, right? Your so there's a major customer centric. Your another is the revenue targets, right? Your margin targets. So those things you can service level. So these are some of the metrics which you can actually achieve if we are able to meet our production, or if we are able to meet our capacity as per the takt time. So in 1 minute, suppose if I have my total production, which are total forecasted 2000 units, and I have to work in one shift. So in one shift, I have 480 minutes. Sometimes what happens is we have 480 minutes. For example, we have 480 minutes in one shift, but it is not possible to, not possible to consume 480 minutes total. So maybe suppose we have some setup time, right? We have setup time. So per cycle, per cycle, suppose per lot, right? You're losing some certain setup time. So let's say you're losing around 20 minutes of setup time. And then what is happening is you're also, having some kind of breakdowns. You have had some kind of breakdowns. So breakdowns could be around, let's say, 30 minutes per day, right? On an average. So, what is happening over here is that you're losing certain kind of time in the, so in 480 minutes, for example, is a total available. And then what is happening is we are losing certain kind of time. That is 20 plus 30 equal to 50 minutes. So the total consumed time or total use time is 480 minus 50. That is 100 and 430 minutes. So 430 minutes is what we are going to use. So now suppose I have a forecast is the forecast is 2000 units, and my available time for production is 430 minutes. So the takt time in this case is 430. So here 430 minutes is for 2000 units. So in 1 minute we can produce 2000 by we need to produce 430 units. Or other ways. So we have 2000 units which needs to produce in 430 minutes. So in one unit has to be produced in 430 by 2000 units. So one unit has to be produced in 2000 minutes. So one unit will take has to take 0.215 minutes, right? And suppose we have so this also we can say this is our takt time. So how much time a unit should take as per the customer demand fulfillment. So if my customers are giving me 2000 or 2000 units, right? So my I need to produce one unit in 0.25 minute, 0.215 minutes, so that I will be able to deliver the goods to the customer in a time. So that is what we need to see. Okay. So what is this is what we need to compare for each our work centers. So what is the work centers if a product is passing through, how much time a work center is taking, what is the bottleneck, and how much is a whether it's matching the tag time or not. If it's not matching the tag time, what should we do? We will look all those things into picture in the upcoming session. So let's say now we are seeing that our input, we have seen the forecast. So this is a factory. So what the first input we have seen is forecast per unit time, right? We have understood what is the importance of time, right? So that time is going to define a major part of our optimization in the forecasting. Now we also see we converted this forecast per unit time into tag time, right? So we converted this forecast per unit time into tag time. So this is another thing which we have seen. Now what we have, we need to have raw materials per unit time. Plus we have also taken the safety stock as an input, right? What is other things we need if you want to have the production? We need to have sequence sequence of work centers. Sequence of work centers is called routing. So what is a route? Suppose if you have to produce a product, so product has to go through multiple work centers. Suppose work center one, work center two, work center three, work center four, right? So if this machine is going, this if this product is passing through work center one, two, three, and four, then we say this is a route. Okay. So the sequence of work center has to be defined for a product, and that sequence of work centers is called routing. Okay. So we have taken forecast per unit time, we have taken the tag time, we have taken the sequence of work time, we have taken the safety stock and raw material. Now each and every work center will have will have certain production time, certain processing time, right? So how much time, how much time a product will take. Suppose work center one takes around can produce 2 units per minute. Work center two can produce 1 unit per minute. Work center three can produce 5 unit per minute, and work center four can produce 8 units per minute. Right. So we need to also see how important is the time, right? How important is our time? So time is a very important factor when we are going for the optimization, and that optimize when we do the optimization, the time factor has to be same from input to the output stage. So this input which is having here, this is called our production capacity per work center. Okay. Now what we do, we can convert this production capacity in work center into, so suppose this is actually telling us 2 units in 1 minute, right? How much unit in 1 minute? So 1/2. So 1 unit will take how much? 1/2 minute. So we convert this into 1/2. This is our 1/1. This is 1/5. This is 1/8. So this is to compare our takt times with the available capacity. So we have, okay, this is our available capacity, available capacity. Okay, and we'll compare this available capacity with takt time. What is takt time? We have discovered as in the previous. This takt time is we have to produce 0.215 in one unit should take at the most, not more than this. Okay, it can take less than this, but not more than this. So at the most, it can take 0.215 minutes. 0.215 minutes. So we have to compare this that time with our work center times. Okay, if you look at here, 1 by 2 is how much? Zero point 0.5. 1 by 1 is 1 minute. 1 by 5 is 0.2, 0.5. 1 by 8 is how much? Around 0.12, right? So if you look at here, this is more than the tag time. The tag time was 0.15. This is 0.215, 0.215, 0.215. Only the last case is actually is matching. But other three cases, the three work centers are not matching. Here it is taking twice the time. Here taking four times. This is in this case is twice time. This is four times. This is twice, right? So in this case, if it is taking twice the time, then we need to have two work centers. If it is taking four times, then we need to have four work centers, right? If so, this is what a very important decision we need to take. Suppose if you want to map our customer requirement with the production capacity. So how many machines we require to map the customer requirement? How many machines we require to map the customer requirement? That is a very important decision which we need to take. So here, how many machines we require to map the customer requirement or the forecast, right? This is what we need to look at. So that is how, that's why it's very, very important to have the measurement of the takt time and also the measurement of the available capacity. If you measure the gap between the takt time and the available capacity, takt time minus the available capacity, right? So this measurement can be used to discover the number of machines required. Suppose the takt time and available capacity is x1. Okay. So X1, the gap is there. So how many machines are required to bridge the gap? How many machines are required to bridge the gap? This X1 can be used to understand how many machines are required to map the customer demand so that we are not falling short of the requirement. So this is another metric which we need to think about. So takt time is a very important metric and work centers are very, very important, right? So let's look at the new thing now. So we have understood our inputs. So once again, I format my input here. So the input is forecast per unit time. We're going to convert this into takt time later. Then the raw materials, we know raw materials. The raw materials is how many raw materials we require and how much safety stock we require. That also we have taken into consideration. Then what's your production capacity? We have taken the production capacity. So production capacity we have taken. So we are taking the production capacity over here and the production capacity, then we are going to convert this production capacity into the available capacity in terms of the tag time conversion. And then we'll want to know number of machines required to manufacture as per the customer demand, right? So this is all we are doing over here. Uh, Now we also have to define how much is the ending inventory, how much is the beginning inventory. Okay. So beginning inventory could be like, maybe out of control, but we can actually define our ending inventory at certain time horizons. And the reason of defining our ending inventory is that we don't want to lose customer orders, right? We don't want to lose customer orders. At the same time, we don't want to build over inventory. So that is what the important. So if you are defining the production capacity, you're defining your raw material capacity, if you're defining your production capacity, if you're defining your tag time, right? You're good. But everything has to work in certain kind of boundaries. So what we are seeing that we need to define our ending inventory. The reason of defining the ending inventory is that we neither want to lose customer orders or we don't want to have higher carrying cost. So our model should know the limits. Our model must know the limits that whether what is the ending inventory it should have. An ending inventory decision should be based upon we should not be losing the customer orders as well as we should not build higher inventory, higher carrying cost. Right? That is what we need to also give the input to the model, into the model or to the factory. That what is the ending inventory they should manage. So if you want to understand, suppose you have to manage everything, what you need working capital, right? So what this company does is they borrow this working capital from banks, right, at a fixed interest rate. So the working capital is also an input, or this could be also a constraint, right? Some companies might be having some constraint on a given day regarding the working capital. So you also have to take into consideration the working capital. Okay, number of people working on the factory, number of people working in the factory, right? This also another constraint. So sometimes some days you might be having less number of people, or sometimes because some people will only leave, some people might be shifted to some other locations, right? So number of people is also working on the factory is also one of the input we need to take into consideration. Now the other input is energy. Energy is your electricity or diesel generated machines, right? So power source, or let's say power sources, we say generator. So electricity is also one of the input. So what is your input? So you need to have a right energy source, a right electric source, and that source has to be right. Has to be there. The other is input is your secondary or secondary source of machines. Suppose your primary source of machine fails, you have a secondary source of machines to use it, whether you have it or do not have it, right? Or if you have any problems, then are you doing any outsourcing or not, right? So you also have to define your outsourcing volume per day in terms of in case if you have any kind of breakdowns or something, or that also has to be defined here, right? The other input which you have defined is your the transportation volume per day. And once you define transportation volume per day, you have to also define transportation cost. So the transportation volume per day, suppose if your production, your suppliers delivery, and your forecast, your production, and your dispatch, right, all are matching. But your transportation which is happening between supplier to production and production to customer, right, this is not matching. Transportation rate is not matching, means volume, right? Then I think our entire plan will go wrong. So the transportation is also one of the input when we take into the overall consideration, because our product, our the entire supply chain has to be mapped. Okay, so these are the inputs which we are taking into account. So I will share with you one table. If you look at here, the inputs which are going. So what is the inputs versus raw material? So the cost of raw material is an important parameter when we are going for production in the production planning, because if you are if you are focusing on actually minimizing your cost or maximizing your profit margins, right? So you need to see the raw material cost is one of the input, right? Next is energy cost. Similarly, if you want to optimize your energy cost, if you want to optimize your overall production cost, then energy cost has to be also has to be seen one of the factor. Setup cost, right? What is setup cost? Setup cost means suppose you're setting up your machines, so you need to spend some time on setting up the production before you start the production. Setup cost, right? So interest to the working capital. So what suppose you're paying for 4% or 5% or 10% to your on the amount on the money you're borrowing from the bank or from the investors, right? You have to pay the interest. So that is also one of your cost parameter, manpower. So how many people are working on a particular project. So that is also a very important aspect from the cost point of view. Transport cost, right? Transportation cost. So transport cost is also a very important part, because the transport cost is going to impact your overall production cost, because we are trying to optimize the cost till production. Okay. So sourcing cost. So what is your sourcing cost? Because you need raw materials, you need to also plan for outsourcing. So there would be some kind of sourcing cost involved. So what is sourcing cost? Then the planning cost. Planning cost means that somebody has to do the entire planning, right? The amount of money spent on the planning cost, on the assignment cost of the products, of raw materials to the products, is also something a very important cost. Technology cost. So you're using various different technologies, like here you're using ERP, some software forecasting tool or some kind of Excel tools. So you might have spent some money on buying those technology products. Carrying costs, right? So suppose if your inventory is crossing certain limit, then you have to or maybe how much money you are spending on storage of the products, so or raw materials or WIP or semi-finish. There is a carrying cost. Similarly, the stock out cost. So stock out cost is suppose if you're not able to produce on a given day so that you are able to dispatch it to the customer. So stock out cost will be there, and there is that means there are two kind of stock out cost. One is your revenue loss, other is your penalty. Okay, so those two things can come into here. Then your machine idle time. Suppose your machine is there, but it's not actually running. So because even though the plan was there to manufacture, but we are not able to run the machine, so that is still idle time. Suppose if the production is not scheduled and machine is not still idle, we may not include that idle time as a one of the cost parameter. But if the production is scheduled but we are not running the machine, in that case we are going to have the machine idle time. Okay. Then last one is the over machine usage, right? So if you're producing extra products, extra volume, then the required one, right? That is the over machine usage. And sometimes, we also have to go with the MOQ. So in the MOQ, that we have to consider separately. I'm not including that particular model. So minimum order quantity. So minimum order quantity is called MOQ. So that parameter we look into in a different case. Okay. So here we have some certain kind of cost parameters, and these cost parameters will put into our production planning model. Okay. So in some of them are variable costs, which are based upon the production. Some are fixed cost, right? Some of them are fixed. So whatever is the production volume, the setup cost will be remain same. Whatever is the production volume, the interest will be same. Whatever is the setup cost, right? Uh, the sourcing cost will be remain same. Whatever the production volume, the planning cost will remain same. Whatever is the the setup production volume, the technology cost will remain same, right? So the carrying cost will differ based upon the production volume. The stock out cost will differ based on the production volume. The machine idle time will, may be depend upon the production volume. The over usage will also depend upon the production volume, right? Energy cost might depend on the production volume. Raw material costs depend on the production volume. So some of the costs are fixed, some of the costs are not fixed. So it depends upon the volume of the production. And some will not depend on the volume of the production. Irrespective of the volume of the production, they will remain fixed. Okay, so these are cost parameters. Now let's look at the forecast. So this is our forecast for each product, and the time horizon is 2 weeks. Okay, we are taking for 2 weeks time horizon. Of course, we're calculating the forecast per day, and for 14 days we're calculating it here. So here we have 17 products, and what is we have been given the initial inventory. What is the initial inventory at every stage, and we're also trying to take into account whether raw material is available or not available. So here we are taking a case where raw material for each and every product is available. So if the raw material is not available, then the model will change. Right? If the raw material is not available, the model will change. Right? So now we have a day wise forecast over here. And after day-wise forecast, we're calculating our average sales. Okay. And now we're calculating the ending inventory. So the ending inventory is calculation. We are making a decision that we need to have 2 days of ending inventory. So I'm multiplying this average sales into days of supply to calculate the ending inventory. Everywhere we're doing. So this also can be changed. Somewhere you can keep more days of supply. Someday you can keep some products you can keep more days of supply. Some products you can keep less days of supply. In some products you need not to have a days of supply, right? So like this, you can actually decide your days of supply. This would be based upon your model, how many days of supply you want to have for each product, right? And based upon that, you can actually decide your ending inventory. In some cases, you don't need ending inventory because you don't need to days supply because the customers are very predictable, or the demand will not be realized. Okay, if your demand is variable, I think then in that case we can actually have, or demand is variable or raw material supply is variable. In that case, we can actually think about creating a days of supply. Okay, now we are going to go for the work center plan. So suppose if my product one is there, product one, I have 6 work centers. So and this is a binary this is an assignment. So product one will not pass through work center one and work center two and work center three. The product one will only pass from work center four and five. So if I have to manufacture product one, I have to use only two machines. They have work center four and work center five. So work center one, two, and three and six will not be used in manufacturing the product one. Similarly, product number two, if you have to manufacture, I have to pass the product raw material from work center one, two, and six. Right? If I have to manufacture product three, I have to pass the raw material first into work center one, and then after work center five. Okay. So this is my route. This is called routing of the products. So how the products will be selected for manufacturing through work centers. Right. This is the routing. Now let's go into here. So what is the capacity of the work center one? So we can produce 7 units per minute. So this is the capacity, but not in the not capacity units per minute. We have to define in minutes per unit also, that we will do in a model. So this is 7 units per minute, 10 units per minute, 7 units per minute, right? So now what we have to do is that we have to link this routing with the capacities, because if you look at a product one is not passing through from work center one and work center two and work center three. So product one will not require work center one, two, and three. So what I'm going to do, I'm going to multiply these numbers with these numbers to create a third actual routing based capacities. Right? This is routing based capacity. So here, if you look at here, I have multiplied this number 0 with 7. So I got 0. Now we need 0 because our product one is not passing through walk 1, 2, and 3 and 6. So if you look at 1, 2, 3, and 6 are 0. Only 6 and 8 are populated. So means work product one will pass through 6, works into 4 and 5. Works into 4 has a capacity of 6 units per minute. Work center 5 has a capacity of 8 unit per minute. Right now, what we have to do, we have to